Coding using TI-Nspire Calculator, the bisection method. And well, the bisection method is a way of finding the approximate solutions of an equation in the form of f of x, where f of x equals to 0. So, and give an initial approximation where the solution of x should be. So let's actually use the bisection method. Let's code the bisection method using the TI. Let me show you how that's done. Alright, this is CAS. Go to menu, functions and program. So we're going to use the program this time. Okay, so that is the bisection method. So you put it bisection. And you could save in the library, whichever library you happen to use. So let's get this one here in the private lib. Okay, so we're going to define our function. So to define, we're just going to go menu again, define variable. So variable is f of x, where equals to x cubed minus x minus 1. So press enter. Local, we're going to localize our variables. So local there, up there. So the variables we're going to use will be the left end, the right end. So the solution is in between the left and the right end. So left, and the number of iterations we have to make. Alright, we also have to put the variables here, a, comma, b. So a is approaching the value, the left, from the left end, the root of the x from the left end, and the right end. Okay, so let's move on and back here, press enter. So we're going to request our left end has to be a, and we'll just press menu, input output, request, and we need to use the quotation mark or the speech mark. Press control, the time sign, and we're just going to put left from the left end and put colon, press catalog, and number 4, that's where your colon is, and comma, that's a. Going to do the same thing for B as well. Local input request. So again, the control, the time sign. So this time the right end. B. You'll do the same thing again. You can edit that if you want. Speech mark. So this time is the number of iterations we have to make. So the more iterations you make, the more accurate your result happens to be. Then we're going to put 4n. So to get that, just going to have to go to, alright, now press menu, control, 4n, 4. So for the 4, we're just going to put I, comma 1, comma n. Alright, now we're going to put our condition now if. So this time here, before we put the if, we need to put the midpoint. So remember that the bisection method is a way of actually finding the x-intercept. And assuming that the x-intercept is within, a value and b value. So let's find out the midpoint now. So we're going to put the midpoint, and we're just going to define that. Press control, the template that defines your midpoint, and control the division sign that gives you the division template, a plus b. So you actually that gives you the midpoint of a. So now we put after we put the midpoint, this is what we put the condition. Press menu, control, if then. So we're going to have to use if then. So if then else. Okay, that one there. If then else and if. Okay, now if, so we're going to say if the f of x, when you substitute the f of x, the a value, which is the left end, times, when you substitute the midpoint, in this case letter p, is greater than 0, is greater than 0, press Control, the equal sign is greater than 0, then put the cursor up there, then take the a value as to be initial guess where the root should be. Press Control, the template, and this time it's going to be the midpoint. Alright, if that's not the case, so else, if that's not the case, we're going to take b, the right end, as to be p. Okay, so now alright, and if, so we're going to display now, we have done, so we need to display now. Alright, so this time we're going to go menu and input output, display at 1, first value has to be, so still use the speech sign, control the times the multiplication sign, a equals to, put a comma, approximate a, going to do the same thing for b as well too. Again, press menu, input output, number 2, comma, the speech sign, equal, comma, approximate, this time b. Going to do the same thing for the iterations. Menu, input output, second, third, this time, the iteration, the speech sign. This time and f of b. Alright, now we finished programming now. We finished coding. So let's see how this one works. Alright, now to store, we're just gonna press menu, check syntax. Yep, that's stored. The program is fine. Okay, now we're going to check if this is working. Press menu again. Number 2, number 3. Alright, now we've been given initial guess in the question. So the question is asking us, our initial guess is, well, the expected root is in between 1 and 2. So let's actually put our left end as to be 1 and the right end to be 2, and the number of iterations that we have to make, let's make it 10. So the more iterations you make, the better it is. So let's do this one here and press enter, and asks you again, is that your left end? You say okay, yep, this is the right end, that's what I want, the number of iterations, and it gives you that. So you can double check if that is the correct value. You can double check and see if that is. So let's say I'm gonna go here. Let's save this one here first before we lose. Save as. So we're going to say bisection, depending on where you want to save it. Alright, save that. And we've got our root as to be 1.3252. So let's see if that's the same case. If, let's say, we're going to go new, and this time let's graph and see if that is the x-intercept. So that was x cubed minus x minus 1. Just enter. That's true. And here we go. That's exactly what it is. All right. That is how the bisection works. I hope that's clear.